Semester exam part 3. Alright, so we're going to pick up with question number 30 here. And question 30 says, look at the graph below. One grid line is 1 unit. Which of the following is the equation of the line? Well, when we look at this, we know that it has a y-intercept of -4. So our b is equal to -4. Now we can determine the slope, and if I add a couple points on, I know that my graph goes up 2 and right 1, so the slope is up 2 and right 1, so our slope is 2, so our equation is going to be y equals 2x minus 4, which is A. When we look at question 31, the table below shows the amount of gas that is in a car's tank t seconds after the gas pump is started. If this pattern continues, how many gallons will be in the tank after 10 seconds? Well, there's two things that we can do. We can write an equation and then evaluate the equation for 10 seconds, or we can just simply extend this pattern. If we notice that the time is increasing by 1, so we can do 6, 7, 8, 9, 10. And then the gallons is increasing by 0.4. So 5.4, 5.8, 6.2, 6.8, 7.2. So what we know is after 10 seconds, there will be 7.2 gallons. We'll have 7.2 gallons in the tank. The second bullet says, is this a linear relationship? Use math to justify your answer. Well, yes, this is a linear relationship because there's a constant difference between x and y, meaning the x value is always increasing by 1. Alright, so the time in this problem, it's time, the x value is time, is increasing by 1, and the gallons is increasing by 0.4. So since they're both always increasing by the same amount, that means it's a linear relationship. That'll give us a straight line. So that's what the linear relationship means, that it's going to give us that straight line. Question 32, Ahmed is ordering rings from a catalog. There's a shipping charge of $5 no matter how many rings are bought. Each ring is $6. He spends $71. How many rings does he order? Well, we can write our equation. We know that the shipping charge, let me get my highlighter. So we have a shipping charge of $5, and then each ring costs $6. So, and we have a total of 71. So if we know that X is the number of rings, we can say we have 6x, because that's $6 for each ring, $6 for each ring, plus our shipping charge of 5 will equal our total of 71. And then we can simply subtract 5. So 6x equals 66 divided by 6. X equals 11. So we can, Ahmed can buy 11 rings. Ahmed can buy 11 rings. Question 33, what's the slope? Well, we know that the formula to find slope is y2 minus y1 over x2 minus x1. So we just plug in our numbers. We have 10 minus 3 over 5 minus 1. 10 minus 3 is 7. 5 minus 1 is 4. So we have 7 over 4. So the slope 7/4. Bubble in my 7/4. 34. Jerome had a leaky tire. He was interested in how fast the air in the tire was leaking. He took measurements at 3 different times, measured the air pressure in the tire that had leaked. The results are shown. At what rate is the PSI per minute, in PSI per minute, is air leaking from the tire? Well, at what rate? This is asking us for the slope. Well, we know that the slope is a change in y over the change in x. Well, we know that for this one, we're going to select 2 of the points. It doesn't matter which 2 you want to select, you'll still get the same answer. So if I select these 2 points, so I know that my y value is going to be, it's going from 28.8 to 27.0. So I have 27 minus 28.8, and my x value is going from 5 to 8. 8 minus 5. So we get negative 1.8 over 3, which gives us negative 0.6, which means it's going down. The air is coming, it's going out at a rate of 0.6 per minute. Alright, so it is leaking at a rate of 0.6 psi per minute. Now the reason I didn't put the negative in there, because the negative means it's leaking, so when I said it's leaking, that's therefore is our negative sign, so I didn't write of a rate of negative 0.6. So that's why it's leaking at a rate of 0.6 psi per minute. After taking a last measurement above, Jerome decides to try to drive to a repair station. The car is safe to drive as long as the air pressure is at least 15 psi in the tire. How many minutes from the time of the last measurement does he have to get to the repair shop? Well, if we look at the last measurement, it's 12 minutes, and there's 24.6 psi. So this is at the last minute now. So we know that the air is going out at a rate of 0.6 psi per minute. So what we need to do here is we need to find out how much longer he can drive on it. Well, we're at 24.6 psi, and we know that in the problem it has to be at least 15. So if we're at 24.6 psi, and we subtract our 15 psi, because we can't go below that, we know that this gives us 9.6 psi. So we have a 9.6 psi left, and it's going out at a rate of 0.6 per minute. Well, we have 9.6 left to go. We divide this by 0.6, and 9.6 divided by 0.6, 9.6 divided by 0.6 will give us 16. So we get 16. So what that means is we have 16 minutes until we can't drive anymore. So we have 16 minutes left in the car, in the tire, until we are completely out of air and it's not drivable. 35. Use the graph below to explain how the change in slope affects the steepness in line. Well, when we look at this, if you notice, we have a half, and this is 1x, then 3x. Well, these are going up, and the slope is going up. So the greater the slope, the greater the steepness. So the greater the slope, the steeper the line. So as the slope increases, the line will become steeper. Alright, we have 4 equations. In the blanks before they use the numbers 1 steepest to 4 least steep. Alright, so when we look at these, I know that my slope is 4, my slope is 1, my slope is 1/4, and when we look at the fourth one, there's no x, so if I add in 0x, I know that my slope is 0. So 1 is the steepest slope, so the steepest slope has the highest value, which is 4, then we have 2, then we have 1/4, and then 4. So it's already in order, 1, 2, 3, 4. 37 and 38, we want to write our equation that shows the relationship between the variables. So with question number 37, the total cost of gasoline varies directly with the number of gallons. The price of a gallon of gas is $3.67. Well, cost varies with our gallons, and it tells us that a gallon of gas is $3.67. So what this is saying is that a gallon, the cost times the gallon. All right, so 367 times a gallon will give us a cost. So that's how we get the cost equals 367 times the number of gallons. Let me erase this here to make it a little bit more clear. So the cost is 367 times the gallon. Number 38, distance is proportional to time. A car travels 65 miles per hour. Well, our distance is proportional to time. Well, it's going to be 65 miles per time. So however long we are, we do that times 65, and that'll give us our distance. When we get to 39, the amount a spring stretches varies directly as the weight of the object attached to it. A 10-ounce weight stretches the spring 12 centimeters. Write our equation. To write our equation, we know that the amount a spring stretches, so stretches equals our weight. We have this time, unlike 37 and 38, it gave us our rate of constant rate of proportionality. We have to figure it out. Well, we know that a 10-ounce weight stretches a spring 12 centimeters. So 12 centimeters over 10, which we can say 12 divided by 10 is 1.2. So we know that our equation is S equals 1.2 W. Or the other way we could have wrote this one is that S over W is our spring over our weight, and we know that the spring is 12 centimeters. The weight is 10 ounces. So we can also say S over W equals 12 centimeters over 10 ounces. And then B says, how much will a 15-ounce weight stretch? Well, we simply put 15 in for our weight, so it's S equals 1.2 times 15. So S will equal 1.2 times 15. I believe it's 18. 1.2 times 15 is 18. So it will stretch 18 centimeters. Or we could have also used our second equation. So we're putting in 15 for our weight. So S over 15 equals 12 over 10. So we cross multiply. We do 15 times 12, which will give us 180 divided by 10, which will be S will equal 18 centimeters. So either way, we got the same answer. Number 40, the number of calories consumed from nuts is directly proportional to the number of ounces eaten. So we know that calories is going to equal our ounces. 8 ounces of dry roast cashews contains approximately 780 calories. How many ounces are eaten if 585 calories are consumed? So once again, we have C is equal to A, 780 calories. over 8 ounces. Or we could do this is, and then we put in 585 for calories, so we would have to solve that for C. So 585 calories equals 780 divided by 8. 780 divided by 8 is 97.5. You divide by 97.5. 585. 585 divided by our answer is 6. So A equals 6. So that is 6 ounces. Or we could set it up the other way too, and it is 780 over 8 equals 585 over X, or A, and we cross multiply. So 5 times 580, or 8 times 585, and we divide that by 780, and we get 6. Two ways to solve this problem. Both ways are absolutely correct. 41. The table below shows the distance a runner is from the finish line. Write a linear equation. Well, to find our linear equation, we need to find our slope. So we know that our y value is going down by 30, and our x value is increasing by 4. So each time it's going up by 4, but the y value is going down by 30. So negative 30 over 4, which we know is 7.5, negative 7.5. So we have our m. We select a point. So now we can select a point. We have our y value is 270. Our x value is 4. So we have to figure out the b. Y equals, actually let me write this here, y equals mx plus b. Y is 270 equals negative 7.5 times 4 plus b. 270 equals negative 7.5 times 4 is negative 30 plus b, and then we add 30 to both sides. So 300 equals b. So our equation is going to be y equals negative 7.5x plus 300. The other way we could have found this equation is we could have used our calculator and simply went to stat and edit and typed in 4, 8, 12, 16, and 20. And then L2, we type in 270, 240, 210, 180, 150. And then what we need to do is our linear regression, which is stat, calc, and number 4, linear regression, which means to enter. And we got y equals negative 7.5x plus 300. So 2 different ways to get the same answer. So now we have our equation. How fast is the runner traveling? Well, this is asking us for our slope. Well, the slope is negative 7.5. So we want to say, well, what does this actually mean? It means he's going 7.5 yards every second. So the distance to the finish line, well, since it's negative, that's the distance to the finish line. So we know it's slope is y over x. Y is our distance, and t is time. So it's negative 7.5 over 1. So this means he's going 7.5, so he's traveling 7.5 yards every second. He is traveling 7.5 yards every second. And how far will the runner be from the finish line after 32 seconds? Well, we can do one of two things. We can just extend our table, and we can do 24, 28, 32. And then we keep going down by 30. So he's going to be 60 yards from the finish line. 60 yards from the finish line. Or we can plug 32 in for our time. So we would have y equals negative 7.5 times 32 plus 300. And if we simply solve this, negative 7, let me clear this, negative 7.5 times 32 plus 300, we get 60. So y equals 60 yards. Same answer, just two different ways to do it. And for 42 and 43, complete the tables below so that the functions are linear. Well, we said that linear functions have a constant rate of change. Well, this is plus 3, so we keep, or minus 3, so we keep subtracting 3 each time. And when we look over here, well, we have to figure out, well, how do you go from negative 4 to 6? Well, from negative 4 to 6, that's actually plus 10. Well, we need to do two things. Well, half of 10 is 5, so we need to add 5 and then add 5. Negative 4 plus 5 is 1. 1 plus 5 is 6. 6 plus 5 is 11. 11 plus 5 is 16. 21, 26. So we are just adding 5 each time here. Linear, they have a constant rate of change. And we'll stop there for now.